Okay, so we have a triangle here, CAB. We're told that CA is congruent to CB, and that these points here, P and Q, are specifically selected so that the angle CBP is congruent to angle CAQ. And our goal is to prove that these two segments here, AQ and PB, correct? AQ, no. CP, oh no, CP and CQ, right, are congruent. So we know that this whole side is congruent to this whole side, but once I make these two smaller segments here, is this just P to C the same as C to Q? I've proved that's true. Okay. Well, this isn't too bad. So we're going to start out with saying that CA is congruent to CB, and we're going to say that angle CAQ is congruent to angle CBP. Okay. That's just given. Okay. Now, by the way, this proof is going to follow kind of a familiar pattern. We're going to find two triangles. We're going to prove those two triangles are congruent. And then because those two triangles are congruent, we'll know that certain corresponding parts of those two triangles are therefore congruent. So it's going to turn out that PC and CQ are congruent, or corresponding parts of congruent triangles. Okay. So next up, we have the angle ACB is congruent to angle ACB, congruent to itself. And anytime something is congruent to itself, it is the proper, can't spell, reflexive property, right? Reflexive, think reflexive, reflection, looking at yourself in the mirror, the same as your reflection, the same as yourself. Reflexive property, anything that's the same as itself. And why do we have to say that something is the same as itself? Well, because it happens to be that angle ACB is a part of two different triangles. There's one over here, triangle ACQ, right? And it's also part of triangle CPB over here. Actually, I guess if I'm going to say ACQ, I should say BCP. Right? So those two triangles. Right, so one of them would be kind of, shade it off there. That triangle right there. Squeeze that little line on the side, and then that triangle right there. So those two triangles. Maybe we'll have that angle up there. Why is that important? Well, because that gives us, over here a little bit, I could shade this off somehow. Yeah. This doesn't help a whole lot, I guess, but alright, that gives us angle, right, congruent, and then I have all the way down side, and then I have angle in the corner, angle, side, angle. Right, and then on the other side over here, the same, it's the same angle, the same side, and then the same angle down in the corner. So if I have two triangles, I have two matching pairs of angles, two pairs of congruent angles, and the side in between them is also congruent, then those two triangles are congruent. Which means that triangle CAQ is congruent to triangle, if everything is correctly, CBP. Right? And that is again angle, side, angle. Now that I know these two triangles are congruent, I know that these two parts of the triangles, CP, must be congruent to CQ. Right? Because they are corresponding parts of congruent triangles are congruent. Okay? So again, the trick here was to find a pair of congruent triangles, or a pair of triangles that are congruent, prove they're congruent, and once we know that they're congruent, any corresponding parts of those two triangles that have already known are congruent are also congruent. Now we are asked to go just one step further and prove that this shape in the middle here is a kite. To be a kite, it has to have these two sides being congruent and these two sides being congruent. So let's see. We already have that these two sides are congruent, CP and CQ. So let's see if we can find that KP and KQ are congruent. We have a couple of small triangles here. So let's see. Let's say that angle PKA, right? PKA is congruent to QKB. Now, we know that because these two are vertical angles. Okay. And then we also, so therefore we also know that APK is congruent to BQK. Now, this is, we could go through all sorts of little steps, but basically, the three angles in a triangle add up to 180, right? So if I got this little triangle right here, three angles that add up to 180, this little triangle over here, three angles that add up to 180, and if I know that this one's the same as this one, and this one's the same as this one, if you think about it, 180 minus this will give us the angle up here in the corner. And over here, I'm subtracting from 180, I'm subtracting the same angle here and the same angle here, so I'm left over with the same amount for the third angle. Right, so these two third angles must also be congruent. And sometimes this is called the, I've heard this called the third angle theorem or something like that. Right? So if you know two angles in a triangle, you know the third. If you know two triangles have two pairs of matching angles, you know the third pair also has to match because there's only so many degrees left over for that angle. So let's mark that. Now you've got, now if we just had that any pair of sides in these triangles were congruent, then we'd know the two triangles were congruent. And then we could say, well, then PK and KQ are congruent. And in fact, we can actually prove that. We could say that PA is congruent to QB. Now this one again is a little bit tricky, and we could break this down into a million little steps. We won't. But basically we already know that CA is congruent to CB. So those are the same distance. If I travel from C to B, it's the same distance as if I travel from C to, wait a minute, yeah, it's raining out there, CA. And we proved in a previous proof that CP to CQ is the same. So if you imagine, I'm driving down here from C and I stop at P, and someone else is like driving along here towards B and they stop at Q, and if I know we've driven the same amount at that point, and we know that overall we're going to drive the same amount if we go all the way to B and P, then we must have the same distance left to go. We would say that, I could say that CP, the distance from C to P plus the distance from P to A equals the distance from C to A, and I can do the same over here, and I can say, all right, well, I want to subtract CP from both of those, and they're the same, and I'd be left over with PA and QB, and they're equal to each other, and it's very long here, but I'm going to put in quotation marks here, segment addition. So I've severely abbreviated this argument. I'm just kind of explaining it to you. So now we have that triangles APK is congruent to BQK. And we know that by angle, side, angle. Or I guess angle, angle, side, or whatever. I guess you could have picked angle, angle, side. Didn't really matter. I guess you didn't really need this statement. Little star there. Not necessary. Alright, by angle, side, angle. Right? And therefore we know that PK is congruent to KQ because they are corresponding parts of congruent triangles are congruent, and therefore we know that C, P, K, Q is a kite by definition of kite, right? And of course, I suppose this part of the proof does leave out some things that are up here. Basically, the definition of a kite is that these two sides have to be congruent, and these two sides have to be congruent, and we've proven that much. So there you go.